Everybody assumes that measurement, it's straightforward. You grab your part, you go to your tool, and you trust whatever that reading is on that screen. But in reality, there are tons of variables that can change your results. Temperature, pressure, even your technique, how you're holding your tool, all of that can add up to some expensive problems in your shop. That's why I'm here today, yet again, with the Mitutoyo team. We're gonna be diving into a few things. One, how do measurements change? Number two, how do you properly check a tool? And then number three, how do you use all that information to figure out ways to consistently get accurate measurements every time? And with that, it's time for us to get started in learning how to improve measurement accuracy. I know you all rely on the how-to team for your knowledge, for your education, but even the best of teachers know when it's time to pass it along to the experts. This right here is the Mitutoyo America's education team, Jeff and Josh. How's it going, fellas?
Doing great, thank you.
So to kick things off, because we have a lot to go over today, right? I wanted to get from your perspective, we'll start with Jeff if that's all right. What comes into a good training session?
So we believe in avoiding lectures. That's something that really scares a lot of people. So we believe in hands-on experiential learning. So as soon as they come in, we get the tools in front of them, start playing with it. People learn on the job for a lot of organizations out there. Unfortunately, those skills that they're taught aren't always correct. And they don't realize that some of the skills they're learning can really have big impacts on the quality of measurements they're making. So our job is to correct some of those errors, some of those bad habits that they've learned over time, so that they leave here and have a huge amount of confidence when they return to their organization.
Nice, and even if they don't know their bad habits, because you're learning them on the job, maybe from some tribal knowledge from somebody else, you know, it may not be the company's way of doing it. Yeah. It also sounds like it's not just death by PowerPoint, which I think we all get, right? Josh, what's your take on that?
Yeah, we like to keep our trainings very, very interactive. Having hands-on demonstrations that the students will go through to understand, oh, if I place my fingers incorrectly, I'm gonna get bad data. Or if I have temperature influences or other technique influences, I'm gonna get bad data. So it's much easier to teach and to learn those things with hands-on, with a tool in your hands doing those things. It really helps make it click. At the end of the day, we want students to have confidence in what they're doing, so on the shop floor, they can get good data and make good decisions.
Yeah, well, I'm your guys' student today. I felt like I want to get hands-on with some equipment. I want to check some things out. You mind if we go get started?
Let's go.
Let's do it. When's the last time you saw me get this hands-on? This is what I'm talking about when we look at getting into products and figuring things out. We're in the training lab with Josh. We're going to be going over temperature, the calibration, pressure, techniques, all of it with measurement equipment. Josh, what do you got to start with me?
So we've talked a lot about temperature. So I've taken this micrometer and I set the origin on it this morning. And I've just been hanging on to it, warming it up, trying to mimic what it would be like if somebody were using it all day. So if we go back and check the zero now, or the origin, we can tell it is not reading zero anymore.
What do we got there? That's 2 thou?
That's 2/10.
Oh yeah, it's an extra zero for sure.
Yeah, so having these things warming up over time, using them in your hands, that's a bad deal. You need to be going back and checking that zero very frequently if you're handling them. Or one thing you can do to help with this is just put the micrometer in a stand. This gets your body heat, your temperature out of affecting the tool.
And what does this look like? So that's a temperature when it comes to me handling something, but is there a difference between like a temperature out in a shop?
Yeah, so it's really important, if you can, to let the tools acclimate in soaking in the same environment with the parts that you're inspecting. It gets even worse if you're moving the tools or the parts from different environments that have different temperature changes and they're actively changing when you're trying to measure them. That's a bad deal. You need to let the equipment, let the parts soak in their environments.
It doesn't matter what type of millionths, tenths, thousandths that you're inspecting to, that soaking is good for every shop to stay consistent. We're talking about temperature of the human using the tool. We're talking about the temperature environment when it starts inspecting calibration of the equipment. What else goes into this?
Yeah, so from a calibration perspective, I can't use this tool at all unless it's been calibrated. And the environment that is really important is 68 degrees Fahrenheit. We calibrate all of our equipment at 68 degrees. It has to be that way. That number is a very important temperature. If you're measuring different than that, you might need to be doing some math to calculate, to compensate for your temperature differences.
Nice. And what do you have when it comes to actually using the equipment? What are some tips?
So the caliper is a really classic one that we like to look at. A common question that we like to ask in our classes is, where the heck do you put your thumb? Do I put it here? Do I put it here? Does it matter? Maybe it doesn't matter at all. When I'm measuring a part, should I be measuring at the top of the jaws? Should I be measuring at the bottom of the jaws? Does it matter? Short answer is yes. Yes, it does. All of these things matter. So if I'm measuring at the top of the jaws, I can start putting too much pressure on my thumb and not really affect that measurement too much. But if I go down to the bottom of the jaws and I start squeezing, I can affect that number very, very quickly.
Yeah.
So the technique in your finger placement, the consistency in that is critically important. If your thumb's dancing around or you're handling this thing in all sorts of weird different ways, your ability to feel that pressure is going to not be good. It's not going to work very well if you're using inconsistent technique.
This just goes to show, even if you have a high-end piece of equipment, if you're not using it consistently, it's not going to be reliable. Let's go check in with Jeff to learn a little more. Good to see you again, Jeff.
Good to see you as well.
So we learned a lot about variables that can affect a measurement, and it seems now that we understand those, I feel like some people still may think that I can just take a pair of calipers, I can measure it against a standard, and now this caliper is calibrated. What do you have to say about that?
A lot of times they refer to that as like a verification check real quick, and those can be very handy, but I like to live in analogies a lot. And so what I think of is when I get up in the morning, I do a quick little stretch. All right, body's functioning well. All right, I'm good to go. That's not the same as a full doctor's annual physical, is it? Well, that's the same thing for a calibration of, say, a caliper. Is a quick verification check is stretching, exercising that caliper. Seems like it's functioning okay, but it's not to the same depth and procedural analysis that you're gonna get out of a full calibration. Another part of that is, am I checking all the measuring surfaces across the entire operational range? That's part of a full calibration. I am searching for those errors.
Yeah.
I wanna prove that this thing is functioning at its maximum capacity before I hand it off to the technician out there.
Yeah.
So what you're gonna search for are some of those masters. One of the most common ones is a gauge block. You wanna make sure that these gauge blocks have been calibrated themselves so that I know this can be trusted. So I'm gonna send that off to be calibrated typically at a Cal lab. It's just like Mitutoyo offers here in Aurora, Illinois. So I'm gonna have these traceable standards. I know these are good. I can use these in that calibration procedure. So that traceability and that reliability and that trustworthiness is passed along to the caliper, which is then used out on the shop floor for those parts that are being manufactured.
So even though I have a high value piece of equipment and I can maybe get a measurement out of it, I'm doing this calibration process so I can make sure I'm creating a repeatable, accurate environment to get my measurements. Is that kind of the deal?
Absolutely. The key is trust. We've talked about that many times already. You have to trust your measurements in order to trust the data, which ultimately gets passed along so that the people who are receiving your parts that you just manufactured have trust in them as well.
Yeah. I appreciate what you taught me today. And Josh, fantastic job as well. Today, we took calibration beyond the basics and saw firsthand how temperature, pressure, and technique plays into measurement accuracy in the real world. With this knowledge, you're gonna be seeing new confidence in your machinists and your inspectors to deliver accurate measurements on every job. I wanna give a special thank you to Josh, Jeff, and the entire Mitutoyo team for helping us learn how to improve measurement accuracy.
For more metalworking tips and industry best practices, stay tuned for the next how-to episode and subscribe to the MSC Industrial Supply YouTube channel, a source of original manufacturing content built to make you better.